So when talking about navigation, the first thing is we got to talk about different ways of saying it. And there are two different ways. One is you can use the directions that you're going, north, east, south, west, all that stuff, with a degree in between it. So when you see here is you have north, then you go 30 degrees north and go 30 degrees to the east. And of course, if everybody remembers, not everyone, what? Yeah, not everyone eats soggy waffles. Yeah, because that's how it goes, right? Is that how it goes? Okay. Not everyone eats soggy waffles. Or up is north, to the right is east, to the left is west, and down is south. So there you go. So with that being said, we are going to go north, and then you go, so that means you start on the north direction, and you go 30 degrees towards the east. And so that means this is 30 degrees here. And you follow that all the way around. So, south, so you start in the south, and you go 30 degrees to the east. So you're here. Start south and go 30 degrees to the west. Because south and west, south and east. And then finally, to finish it off, start from the north, go 30 degrees to the west. Any questions about that? The very first direction will be north or south first, always. You never say east. You never say east and go east 70 degrees north. You don't do that. It goes north 30 degrees east or west. So you start with north or south first always, okay? All right. And then the next one goes on. Man, I should add this a little bit better. So the next one is just bearings. And so this one is usually what are used for airplanes, for nautical navigation. The deal is they'll say one number, whether it be how many digits it is, up to 360 degrees, and it always starts in the north and goes clockwise. Whereas before with the unit circle, we've always started here and gone counterclockwise. Well, for this one, you always start on the north and you go clockwise around that way. So when we see a bearing of 30 degrees, we start here. This is dead zero. And then we go 30 degrees clockwise. Thank you, guys. Thank you. So there's 30 degrees. So bearing of 30 degrees has the exact same way of saying north 30 degrees east. They give you the exact same spot. Any bearing that you have that's in the first quadrant, you could also say north something east. But beyond that, beyond this first quadrant, you can't use navigation anymore in the same way. All right, 150. So again, we start on the north. That's 0. You go around to 150 degrees. $210. And then finally 330. Bless you. All right. There you go. There's bearings. And so that way, there's two different ways of them trying to give you direction on a compass map. Okay? So when you look at it here, as you can see, with the compass looking at it, of course, you don't need to worry about this because it won't be that per se. But when you see something like this, you have your bearings here. If you notice, north is dead zero. So whenever you're hiking or something, if anybody's done any kind of survival, anything like that, hiking thing, you kind of look at the compass and say, okay, put north and see which way you're facing, and so it helps you kind of put your direction there. And of course, as you can see here, this is another breakdown. This is all new this year for this, but this is a breakdown of what those north and east and south and east and all that stuff looks like. All right? Any questions, guys, about bearings? All right. This part of it's not too bad. It's when we now start getting into some problems, okay? My recommendation to you guys for these problems, read the whole problem first and make sure you draw large large figures, make sure you can see a lot of stuff, because you're going to break down where they change bearings and change directions. You're going to break down a lot of angles inside of there. So you're going to have this coming here and then change direction there, where you're going to break down all those angles inside that little change of direction. So I always recommend trying to draw them a little bit larger so that you can see everything that's going on inside. Okay? So a ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. Then it changes course for 230 degrees, continuing at 15 knots for 3 more hours. At what time? At that time, how far is the ship from where its starting point is? So the first thing is we have a ship going 300 degrees. So I start here, and we're going 300. Whoops, 300 degrees is not there. I recommend doing it here. And I always draw a crosshair. I always do that to help me with direction on where we need to go. Bless you. So we start at the north, and we go around clockwise 300 degrees, and we draw our line, which represents his path. So, and I typically do that here. I try to draw as much scale as I could. I'm not looking for perfect scaling, but we are trying to get, hey, if this one's 300 and the other one is 500, make sure that the 500 is longer than the 300. It kind of helps you really sort out angles and stuff, okay? So this one's going to be what? For 2 hours at the speed of 15 knots. So that's 30 miles, right? So we're at 30 miles. Then it changes course to 230 degrees, continuing at 15 knots for 3 more hours. So we change to 230. Another crosshair here. 230 puts us somewhere out here. And I usually draw sorry, I'm trying to get my not very well centered, is it? There. So with 15 knots for 3 hours, that's 45. So I'll make it a little bit longer than my 30. And now it wants to know, that's not very good. What time, or how far is the ship? Oh, at that time, how far is the ship from the starting point? So it wants to know what this distance is right here. Okay? And so we got to think about all the setups we have for the quiz we just took. We have all these options of angle, side, angle, side, angle. And so we look at our side, and we'll look at this scenario here, and it looks like what we have is, I need to draw this one a little bit better here, put this in a different spot. And what it looks like is we have a side here, and it looks like maybe we can find that angle. And if we can find that angle, then we'll go ahead and go from there. Now, you avoid, so then you're like, well, what about using this angle right here? Guys, we can't use that angle because this line right here, we don't know where it really connects with the old one. We don't know what angle it connects from where it started. Because remember, guys, these are not drawn to scale. So we don't know how long that other leg really is. The angles aren't right at the right angles. So you can never use this type of scenario here right off the bat. So we're going to go ahead and use the angle that's up at top. And this is why I say I recommend probably doing the best you can to draw as large to get that stuff, that gap in the center there, okay? So when we go through here, we say, okay, we got to see a few things. So we go through some calculations. We got to figure out what this angle is from here to here. So maybe we can look inside and break some stuff down in there. And so as I start to read this, I start going through this, I start recognizing, hey, there's a few things I can do here. I could maybe find this angle and that angle there and then add them together. We could do that. Because the good news is we have 180 and 90, we have those really marked off. So maybe this angle right here, well, it's 230 degrees from the north all the way around to where it stops. What major axis did we pass along the way? What's the most recent major axis we passed along the way? This one right here, right? That y-axis, correct? Which means, hey, how many degrees is it from here to here? What? What's half a circle? 180. Well, if it's 230 degrees, and I passed 180, how far did I pass 180? Say it. 50. That little segment right there is 50 degrees. All right, now all I need to do is find the right segment, and then we're good from there. This is where geometry comes in. Any ideas? Do you remember alternating interior angles? These two lines right here represent north. Those are parallel lines. Agreed? They're parallel lines. Well, whatever this angle is right here is also the angle that we're looking for. What is this angle here in the bottom? If I started here, went 330 and stopped, is it 330? Or 300, sorry, 300. I should write that down. It's kind of a big deal. If I wrote down, if it went 330, how much did I miss to get all the way around? So this is 60 degrees. Which tells you now, since it's alternating interior, this is also 60 degrees. All the little ways that they showed you how to do them. There was like, I think they called them the armpits, or it was the Z, and it's inside the Z's, or the N, it's inside the N's. That's what we're talking about alternating interior. And that's why 60 on the bottom right matches 60 with the upper left. It's because they're alternating interior. Due to the fact that true north is parallel with each other. So, for a total of 110 degrees. And then from here, what do we do? Law of cosine. If you don't have a calculator, go and grab one at this moment, please. You might need it quite often today.
What always become a sign, or will it ever be signed for this one?
It could be sine also, but not for this particular example.
Will it tell you specifically, or will you figure it out yourself?
You have to figure out yourself. There you go. So by the looks of your grades from your quizzes, you guys have got law and cosine and law of sine down, which is good. And now we take a navigation and bearings, and this is going to be the hardest part of your unit, is navigation and bearings. Okay? And it all comes down to drawing the diagrams and finding the angles. That's what it really comes down to, is finding the angles. That's what's hard. I've been tutoring students for many years, and basically when it comes down to this, all we talk about is just a whole bunch of examples of just drawing pictures and trying to make those, find those angles that we need. Everybody get 62.04 miles? Good. All right, let's go on to the next one. See if I can draw these better. It's really hard to scale it with this thing that I draw on because it's hard to see at different angles. Okay, plane flies 600 kilometers in a course of 300 degrees, then flies directly south for a while, and finally flies on a 40-degree course to return to its starting point. Find the total distance traveled. All right? So the plane flies 300 degrees. So we started with 300 degrees. See if I can do this larger. There we go. And I gotta figure out where 300 degrees is. Let's try this again. It's at the bottom. All right, so there's this. Sorry guys, I'm not changing anything, I'm just drawing it larger. All right, it's for 600 kilometers. Then it flies directly south for a while, and finally flies at 40 degrees course to return to its starting point. Okay. I'll have to move this. Sorry guys, I know I can do this, y'all can't, I'm sorry. Because now if you look, he went down south for a while, and then changed course 40 degrees. Let's go back to where it started. So as you can see, everything's all different sizes. So as you can see here, guys, what we're looking for is the total distance traveled. So we need to know this, and we need to figure that one out as well. So this was what Sean was asking just a while ago. He says, do we always know if it's going to be law of sine or cosine? The only way you can tell is by the way the problem's set up. Right now they only give us one angle and one side. Do they correspond with each other? Is it the side that connects with the angle? So we're probably going to have to use what? Law of sine. If you have an angle and its opposite side, because remember, what's sine again? Way back in geometry, SOHCAHTOA, what's sine? Opposite over hypotenuse. Opposite. Sine is opposite. That might help you make that connection. If I need to do anything, because now it's open for anything. Now it's open for whatever, so opposite, there's sine. So law of sines is it. So if I find the opposite here, well, what do you think the first one we're going to find is? X or Y, guys?
X.
Y. You're exactly right.
Because there's an angle in the triangle.
I have something going on here. I don't have this angle yet, but you know what? I have enough information here to help me figure it out. Y'all agree? So with that being said, let's go ahead and figure out what this angle is here on the right side. So, any ideas? Johnny?
No, I think one part is 30.
One part's 30?
Yeah.
Which part?
The top one.
Here?
Yeah,
How do you get 30?
because half a circle is 180, and then a quarter is 90, and then that makes 270, so it's 300.
There you go. From here to there is 270. And we had to go 30 more to make it 300, right? So he's right. This right here is 30. Good. He's right. Because 270 minus 300 is that 30. That's that bit right there. How can we find this bit? Look what we have here. You see this? Do you see that, guys? 40 is not here, but 40 is where? Right there in that gap. So if this is 40, does that help? It does help. Why? There you go. When it says these two add up to 90 right here. So the angle I know and the unknown adds up to 90. So what does that mean the unknown is? 50. for a total of and that's what I'm talking about. It's all the little angles. That's why this one looked a little bit better for me. That's why I like making these pretty large. So you can see all these little angles that are in there that's going to give you the segment you need. And all it is, guys, is problem solving. That's what it comes down to. Is finding what Johnny saw, which was, hey, that's 270, so 30 more makes that. Those are big. Finding your 90, 180, 270, or better yet, falling short. Because what happens if we go all the way around? How many degrees is that? 360. So what is this angle here, guys? 60. 60 plus that equals what? 90. So another way of doing it, right? Mason?
I don't know if I did this wrong. I got the same answer, but I did 60 and then did like I found like the top right there.
You found that one up there?
Yeah, I found.
How'd you find that one?
I thought like it was outside of it, inside since they're parallel. I thought that was 60. And then I did like how triangles into the line.
Mhm.
Subtracted 60 and 40. Is that wrong?
No, you still got 80 though as the angle, right? What'd you get the angle up here at the top?
60.
Yep.
I did like 360 minus 30.
So what Mason did was he did the 360, subtracted, this is 60 right here because of that. Alternating interiors, that gives you another 60 as well, right? It's perfect. It's exactly right. Because 60 plus 80 plus 40 is going to give you 180. There you go. So you're right. You can check that way too. And now it doesn't really matter if we get X or Y first, as long as we get one or the other, right? But we have to get both. So let's go ahead and start with X, just to go alphabetically. So sine of 40 over 600. Sine of 80 over X. So 600 sine of 80 over sine of 40. And you should get that leg equaling all right, 119.25 kilometers, but whatever. Now let's go ahead and finish off with the other leg. And unfortunately, you have to do the exact same thing. So, sine of 40 over 600 is equal to the new angle that Mason found, which is 60 over y. And so you should end up with 808.38. And now there's our three sides now, all there. So to find the answer, you add them all up. There you go. Of course, as I said before too, guys, when it comes to this section, all about the drawing. This is very important. Okay, make sure we get all of it. Give yourselves plenty of space to draw everything out so that you can see what Mason saw, which is the alternating interior angle there, or we can see these two add up to 90, so we need to do our math in there. So that's kind of all we're looking at there. So basically the only thing you're going to pull from geometry with all those proof stuff was alternating interior. You're going to see those a lot. A lot. And then beyond that, it's just subtract it from 180, subtract it from 90, something else along that ways where you're just adding or subtracting angles. That's it. But a lot of it's going to help you out. If you get stuck, look for an alternating interior. That's probably what's going to get you out of the mud. Okay? All right. Any questions about that one, guys? Okay. And as you can see, it's all about examples. That's how you find these problems out. That's how we do word problems for most parts. It's all about examples. All right. Starting point V. Starting point V. Town T is 8 kilometers northeast, so north 45 degrees east of village V. City C is 4 kilometers from T on a bearing of 150 degrees from T. What is the distance from C to V? All right. So let's go ahead and start drawing this one out. Town T is 8 kilometers northeast of village V. So we have V. Town T is northeast, so it's over here. This is T because it said, I need to move this. Come on. So there's that. City C is 4 kilometers from T on the bearing of 150 degrees. Oh, great. So we have erasers, right? What is this, C? 4 kilometers. As you notice, I shortened it up a little bit, guys, because we have 8 kilometers compared to 4. So I'm going to make that line shorter than what the 8 kilometers is, just so you can get a better idea of what's going on. So 4 is here. And this is what, is it 150, right? 150, okay, thanks. Then it goes, what's the distance from C to V? And so they want to know what that is right there. Right off the bat, what do you think we're going to use here to find that distance? Law of cosine. You see the two sides? And some piece of angles that we can figure out there? Law of cosine can work. And the reason why we couldn't, because you're like, well, what about this angle? We could find this angle maybe and use that side, or we could find this angle and use that side. Remember, guys, this is not drawn to scale. We don't know exactly where this angle is coming out at. We don't know that bearing at all. So we really can't use the dashed lines. That's why I always put a dashed line there, just so you know that's the unknown. Okay, that's the unknown. So you can't really say, well, that's coming in 45. There's a little off there. We can make that work. Now let's just go ahead and go in here. So let's zoom in on the top section there at Town T. We've got 2 angles again that we got to figure out. So anybody want to start with one angle? Yes, Johnny. There you go. He's right. This is 45, and that's 45 inside. Good. Anybody want to do the other angle, Victoria?
For the top angle for the other side,
Yes.
you do 150 minus 90 degrees makes 45 degrees.
Yes. Do that. Did y'all hear what she said? Go through there. We could also do, well, if we go all the way down to the bottom, how many degrees is it? 180. So how short are we 180 from that 50? Right? We could do that with 2, but yeah, yours worked as well. I mean, it was great. And it's all about finding those 90s and those 180s. That's exactly what it is. So with that, we add those together and we get what? 75. And now we're set up for the law of cosine as we talked about. We got 84. What's the measuring kilometers? What if we were asked? What if we were asked the bearing from C? How far is C from B and at what bearing? So we actually need to find that angle. How can we go about finding that angle? Okay. You gotta be careful here because remember, we don't know where this one's at. Johnny?
Like, do we have X? Like, is that 7?
We do have X, yes. You could do law of sine, but remember, and it's something we kind of talked about, if you start off with law of cosine to find an angle triangle, which we did, you need to continue with law of cosine. But we can still use law of cosine. Sine will get you some law, and we're going to see when I give you all's quizzes back, because it's something we're going to talk about for just a moment on that, okay? But if you stick with it, stay with it, okay? So let's go ahead and use law of cosine real quick to find that angle right there. Let's use it to find this angle. So, what we got? 8 squared equals 7.96 squared plus 4 squared. Cosine of C. Since we're finding an angle, it's going to be inverse cosine. And so that's what you put in your calculator. So what is the angle C? .04. Perfect. That's exactly what I got. There you go. Now you can find the angle from town T to town V from looking at C is 76.04 degrees. Now, and I just wanted to bring that up, guys, because we're talking about it, and I think Kinsey or somebody said last class right before we took the quizzes, if I use law of cosine to find some side here, well, now I can use law of sine, because now I know an angle and its side, and I can do that the rest of the way. Make the long explanations short, you can't do that. You can't switch from law of cosine to law of sine. You get answers that are off. Okay? So if you started with law of cosine, you have to stick with law of cosine to finish off the triangle. All right, guys, I'm going to let you try number 4. You and a partner work together on number 4 and see what we can get. You and a partner work on number 4. Let's see what we can get.
It's not good, 9:45 yet.
That one's a little slow.
So out of it, I think it's 3
Okay. We're going to go ahead and figure out what that angle is there by 50. So what you can do now is you can say, okay, this angle, the side opposite's 3. So 3 squared equals 2 squared plus 4.55 squared minus 2. I'm going to go ahead and do that. So 3 squared equals 4.55 squared plus 2 squared minus and then cosine of what we do not know, which is the starting point. And so when you do that, you end up with this formula here. Let's see what that is. Three squared minus 4.55 squared minus 2 squared over negative 2, 4.5. 2. So, he's right. It's not 50. This angle right here is what we just found. So that little bit, that sliver, that's up there by the 50. That part, the angle that's inside the triangle is 30.37. And so you end up with somewhere around like, what is that? 6160, so you end up with like 19.63 is this angle over here. Which sometimes is assuring if you're drawing, because then sometimes you're like 19.63, that looks like a 19.63 degree angle. I think I drew pretty well then. Granted, it's not to scale, but we end up with small angles actually adding up to small angles. That means you did a pretty good job of drawing. So it's reassuring that you got it right. All right. All right, class practice, guys. I'll let y'all dive into those.